Hey, welcome back to the Mr. Excel Netcast. I'm Bill Jelen. Today is my last podcast about forecasting. I promise, until I get email from the last 4 or 5 episodes. Today we have a series of sales that really make no sense at all. It just spikes up and down, and neither linear nor geometric forecasting is going to work here. There's something else causing this. So we go back and take a look at the data. Well, this is sales at an ice cream stand. It's an ice cream stand in a park, and we talk to the owner of the stand and says, what seems to be the factors? What happens on the days when you sell a lot of ice cream? She says, well, obviously, if it's hot, I do very, very well. And if it's raining, I do very, very poorly. So we took these sales data and we plotted it along with a couple other columns. One if it rained, 0 if it didn't, and then also the high temperature of the day. And we want to see if there's some relationship between temperature, rain, and sales of ice cream. Now I'm going to use the line est function, but I'm going to use the larger version of line est that will give me all of the statistics. So we start out with equal line est. The known y's are the sales. These are the sales. The known x's are both the columns, the rain and the temperature column. And I'm going to ask for stats. So I'm going to put true here as the 5th item. And because this is going to return several answers, it's actually going to return 5 rows, and it's going to return 3 columns. Now the reason it's 3 columns is because we have 2 different known x's. We have temperature and rain, plus it has to return 1 more column for the intercept. So you always choose 1 more column than you have columns of x data. Control-Shift-Enter is how we create this. It's kind of hard to figure out how this works, but basically you start at the top right corner and that's the y-intercept. So in that case it's 0. The temperature factor is immediately to the left of that. Okay, so in my case temperature was the first known x. That actually starts to appear backwards. So we have y-intercept at the right column, then working backwards from that temperature and rain. And we can build a prediction now that basically says 0 plus today's temperature times 2.13 plus today's rain times negative 110. I've already created that formula here, and you'll see that we get a prediction, and when we plot the prediction and the sales, they actually seem to come fairly close to each other. Now, if you had taken any statistics, you'll know that there's a whole bunch of statistics about this regression that we can get. I've drawn in here a little map showing all of the values that are returned when we ask for statistics. The next line we get is the standard error. The one that I always pay attention to is r squared. R squared says how well is this model predicting? It's a value from 0 to 1. 1 means that it's perfectly predicting what's going on. So a 0.88 means it's pretty good, but there's probably some other factors. Maybe weekends do better than weekdays or vice versa or something like that. Also a whole bunch of other statistics here in case you would need those: residual sum of squares, degrees of freedom, the F statistic, all get returned. The frustrating part is you have no clue exactly which order things get returned in. I always have to turn back to the book to figure out which each of these statistics mean. So using multiple regression is a bit more realistic than just assuming a straight line growth. You can set up some independent variables and see if your dependent variables can be predicted using the regression. Hey, thanks to Leon for sending in a question a week ago that got me started on this whole forecasting thing, and thanks to you for stopping by. Stop back tomorrow for another netcast, which I promise will have nothing to do with forecasting from Mr. Excel.